So in this lesson, what we're gonna do is go through a notebook about some probability techniques and some programming techniques. And this is meant to be just to sit back, relax, and see what you're gonna learn in this course. Okay. So you don't have to write anything down, you don't have to copy anything down, you just sit back, relax, and I'm gonna take you through all this business here. So let's head over to the notebook, and don't worry, we're gonna discuss exactly how to install this on our machine and so on. But what we're gonna do now is focus on a example, and the example is rolling a dice, and we're gonna investigate the mathematics behind it, and then we're gonna try it. Right, well, you're not gonna try. I already did it, but I'm gonna show you. We're gonna see some code, and like how can we simulate a dice so a computer can roll a dice on a yeah. So how can we put that all on the computer? Okay, so let's just start at the beginning, and yeah, don't worry, don't write anything down. Just sit back, relax. Okay, let's get straight to it. So let's zoom in just a bit. Maybe a lot. Okay, how's that? It's pretty good. So, this first one, as I say, it's you're rolling a dice, and we're going to investigate the mathematics behind that. So let's scroll down here. Now you have no, just it's fine. I like to look at pictures and the math and stuff like that immediately. It's great. So what does this say? You can read this later as well. Let x be a random variable that represents the outcome of a dice roll. So the numbers from 1 to 6. So when you roll a dice, you're going to get 1, 2, 3, 4, 5, 6. And we're going to say they all have equal probability. And we represent this mathematically like this. So x here, it's the outcome, or whatever's going to happen in the dice roll. And we say it'll be 1/6 of the time. So 1 in 6 times it will be 1. And that's the same for 2. So 1 out of 6 times you roll a dice, it'll be 2. And what I've done is you can read this later. The notes are all there. I've translated this into English, so you see so x equals you know 1 with this WP means with probability, and so on. So that's the basic idea. And then we can find a way to graphically represent this information. So here I've written some code. You don't freak out about the code. You're gonna learn all this stuff later. So just have a look. So here's this visualization here. So what this is a here on this axis, the horizontal one, the x-axis, that's going to be the dice number. So here you've got 1, 2, 3, 4, 5, 6, and here, well, it's not in fractions, but it's in a decimal. But right at that point there, that is 1/6. So they all have the same probability. So you see, like, okay, what's the probability of getting a 1? So you look at 1, and then you go up here. That's 1/6. That's how we represent things graphically. And then what you can do is make some summary statistics about a dice roll. So perhaps you want to say, okay, if I roll the dice like many numbers of times, in the long run, what's kind of the expected value, the average value? And we have ways of mathematically quantifying this, and you will learn this in the course. This is called the expectation, and we use some fancy formulas to calculate the expectation, which you will learn about later. So don't get too intimidated about it. It's okay. And so you'll learn about what this weird looking E-like thing is and all that. Okay, and so this is, you can just read this in your spare time. And now I have a little bit on simulation. So the great thing about computers is that they can replicate experiments many times. So instead of having an actual experiment where you're rolling a dice yourself, you can program a computer to do that 1 billion times or something like that. So you don't want to roll a dice 1 billion times, it's going to take too long. So you just program the computer to do it, and in Python it doesn't take that long. If you're really good at programming, you can try it in something faster like C or C++. It'll be it'll be fast. So, but you know, that's beyond the scope of the course. So what I've done here is I've coded up this simulation, and it's fine. It's just the functions, and so you learn all this kind of thing here. So here I think this thing here maybe is important. Let's try understand it. So I write some code which you will learn about soon, and what happens is it simulates so size means 50 dice rolls. So here it rolls the dice 50 times, and it outputs what it was, right? So if you kind of want to get into it here, like we choose a random integer, an integer like, you know, just all the regular numbers and negative numbers and stuff, from 1 to 6. But the weird thing about Python is you go the first number and then to the last number, but not including the last number. So we don't include 7. So it's 1 to 6. That's something you just have to get used to in Python. Great. So now let's try like 50,000 times, and it's given like, see, it's kind of suppressed here by these 3 dots. It doesn't show all the outcomes, of course, because we'd be printing out everything all the way. Anyway, and then what we can do after that is we have this array. Array is just a sequence of numbers or box of numbers or something. And so you'll learn about what an array is later. And we can compute the average. So you've got 2 worlds. You've got the probability world, and you've got the actual real life world, like where you're making experiments and things like that. And so let me scroll up here. So this stuff here is in the probability world, where it should theoretically be this. And then you can take some samples, make an experiment, and find the average that way here, using that function there. Okay, so, and there's 2 methods of doing it. Here you kind of manually code it up, and you'll learn about that later. And here we just put in the mean function. That's okay. And so don't worry too much. Like the whole point of it was to see, you know, okay, we get similar results. And this is good because so we get about 3.5 and a little bit more, but that's the noise, that's the error. 3.5. So if you do all these calculations here and you calculate kind of the theoretical value with, you know, the formula you will learn later, you do get 3.5. If you're a bit more advanced, I encourage you to read this notebook, or maybe go through the course, then come back to this notebook and understand some of these trickier concepts. But don't worry, we're going to go through it, and looks like that's the end of this notebook. So what we're going to do is we're going to start the course. So this was lesson 0, and we're going to start at lesson 1. So I hope you learned something, and I hope you're excited, because we're going to learn some very, very useful probability.